Okay. There's something else when it comes to the health complications of obesity that has been noticed, and you'll probably won't have been able to avoid the public health messages about this, and that is it's not just your BMI, it's not just how fat you are, it's where you keep your fat. So it has been observed that the health risks associated with obesity are much greater if your obesity is concentrated around your middle section, so around your waist area. So if you've got a big belly, that's worse than having a big bum. So sometimes they tell you you must avoid being an apple shape. If you're a pear shape, if your weight is down around your bottom and the tops of your legs, then that's not as risky as having that weight higher up around your middle section. So the easy way to check whether you're carrying a lot of weight around your middle section is, of course, to measure your waist. So this is what this additional table is showing you, is that if at the same BMI, the same body mass index, if you're a man and you have a waist measurement of 94 centimeters, then you will have an increased risk of health complications at a certain BMI. But if at that same BMI your waist measurement is actually greater than or equal to 102 centimeters, so if your waist measurement is correspondingly larger, then you will have a substantially increased risk of those complications, those health problems arising. And the same for women, only with a smaller waist measurement. So if your waist measurement is greater than or equal to 88 centimeters, then you are going to have a substantially more risk of the health problems at any particular BMI than a woman with a smaller waist measurement would do. So there seems to be an association between the risk that this excessive fat poses and where it is. And it seems to be that if you have it more around your middle, then that is reflecting the fact that you have more fat packed around your vital viscera, in other words, your abdominal organs. And that will cause more metabolic problems than if you have it around your bum and your hips. This table is simply telling you what I've just said. Here are the BMIs ranges and the classification. So there are 3 classes of obesity here, and here in 2 columns are the waist measurements. So this is the slightly lower waist measurement here, and here's the higher waist measurement. And you can see that in each case, when you have the higher waist measurement, then you have the higher risk of complications as a result of the same BMI. What is it that's going on? Why the health risks? Well, as more and more research gets done, the key factor that seems to keep coming through is insulin resistance. And obesity leads to insulin resistance. That insulin resistance eventually, of course, will lead to type 2 diabetes. But insulin resistance in itself is a stage prior to type 2 diabetes, but it's on the way. Now we know that you're more at risk of becoming insulin resistant, or you'll become insulin resistant faster if you have more visceral fat. In other words, if you have more of that abdominal fat, that central fat. But what is it about adipose tissue? What is it about that fat that causes insulin resistance? There's been a lot of research to try and establish why does fat lead to insulin resistance? And the answer to that is not something that we can and should try to cover in a lecture like this. But suffice to say, there are a whole range of factors which seem to link the accumulation of excess amounts of adipose tissue, particularly around your abdominal viscera, with insulin resistance. It's not a single thing. There's a whole multitude of factors. It's a very complex mechanism. For our purposes, we just need to know that it happens, and that it is a key event, because things really go downhill once that insulin resistance starts. So what happens as a result of insulin resistance? Well, insulin resistance, of course, means that insulin doesn't produce the response it should produce. In other words, the cells that should be responding to insulin, the insulin-sensitive cells, are no longer doing so. What does that mean? Well, remember, adipose tissue is insulin-sensitive tissue. If it becomes less sensitive to insulin, then what happens in adipose tissue? Well, that inhibition of lipolysis, in other words, the inhibition of fat breakdown or fat mobilization from adipose tissue, is lost. So in normal healthy tissue, when there's insulin around, you would expect that fat breakdown is inhibited by insulin. And again, if you go back to the metabolic purpose of insulin, that makes sense, because insulin is going to be released when there's a lot of glucose already in the blood, and therefore it makes sense that a signal would go to the fat stores and say, stop releasing fat from the fat stores because we've got lots of glucose to deal with. We don't need any more sources of energy. But when you become insulin resistant, that effect is lost and you still get fat breakdown even in the presence of insulin. In another insulin sensitive tissue, in muscle, the glucose uptake and glycogen synthesis, we don't need production, the glucose uptake and glycogen synthesis stimulation is lost, because in muscle, insulin stimulates the uptake of glucose into the cells and also the conversion of that glucose into glycogen. If it's not going to be used immediately for energy, then convert it into the storage form and store it up for a rainy day later on when you're going to need it, and you won't have just had a meal. And in liver, which is another insulin sensitive tissue, the suppression of gluconeogenesis is lost when you lose insulin sensitivity. So remember that insulin in a healthy liver would stop the production of new glucose by the liver. Again, perfectly good reason for doing that. Insulin is around when there's lots of blood glucose, and therefore you don't need the liver to be making yet more glucose. What you want the liver to be doing is taking up the glucose that's already in the blood and converting it into glycogen, storing it away, but not producing new glucose. So all of those functions tend not to happen as you start to get insulin resistance. What does that mean? Well, in adipose tissue, it will mean, because insulin is failing to inhibit lipolysis, that you will get more lipolysis and therefore increased release of lipids into the bloodstream, even in the presence of insulin. So far from having its anabolic effect, it's clearing away of nutrients, it's actually failing to stop the breakdown of fats. In the muscle, of course, the fact that it's not stimulating the uptake of glucose and the use of glucose will mean that you get a sustained increase in plasma glucose because you're not shunting the glucose away. That in turn will stimulate yet more insulin secretion, because insulin secretion, of course, is controlled according to the level of plasma glucose, and if the plasma glucose level remains high, then you'll get continued insulin secretion in an attempt to try and bring that glucose level down. And the problem with insulin resistance is not that there isn't insulin around, it's that the insulin is not being responded to. And there will also be a reduction in glycogen stores, because insulin is also failing to get the muscle cells to convert glucose to glycogen, so to store up glycogen. So you're getting this weird situation that by insulin failing to have its effect, you're failing to deal with plasma glucose, so you're getting that really undesirable long-term high levels of plasma glucose, but you're also getting a failure to store up nutrients and therefore a failure to be able to respond adequately when there is calorie restriction, when you're not eating, because those glycogen stores and those lipid stores are supposed to be for use in between meals or when you have to go a long time, when you're fasting. What else is happening? In the liver, you're going to get increased glucose production because you will not be suppressing that gluconeogenesis. So you will be creating more glucose, but not creating more glycogen stores. So again, you're flooding the blood with immediately available sources of energy which can't be used. So the result? Well, as we said, one of the results is that if you're not getting an adequate response to insulin, the response of the system will be to secrete more insulin, so you'll get increased insulin levels. And we know that this, in somebody who is insulin resistant, causes an increase in blood pressure. Now, if you give insulin to a healthy person who's not insulin resistant, it actually will drop blood pressure slightly. But in this situation, we know that it causes an increased blood pressure. So now we have the potential for, once you have obesity which leads to insulin resistance, then you're going to get hypertension too. We also know that increased levels of insulin will lead to activation of the renin, angiotensin, aldosterone system. And what does activation of the renin, angiotensin, aldosterone system do? It causes retention of salt and water, increase in blood volume, and therefore increase in blood pressure. And we also know, of course, that activation of the renin, angiotensin, aldosterone system leads to increased levels of angiotensin 2, because that's one of the signalers that causes the outcome. We also know that increased levels of angiotensin 2 further inhibit the effects of insulin in skeletal muscle. So now we're starting to see a bit of a vicious circle here. We've got insulin resistance leading to increased levels of insulin activating a number of systems, which in turn add to the insulin resistance and increased blood pressure. Insulin resistance, therefore, leads to hypertension. We started off with obesity. We know now that that tends to cause insulin resistance, and that insulin resistance gives a tendency for hypertension. Added to that, we also now know that obesity is a pro-inflammatory state, that the more adipose tissue you have, the higher the levels of inflammatory mediators you release, and therefore the inflammatory markers can be picked up in the blood. In addition to that, the increasing activation of the renin-angiotensin system adds to the inflammatory markers, the chronic inflammation, which contributes to abnormalities in the way that your HDL functions, your high-density lipoprotein. So again, that will disorder your lipid metabolism. So more difficulties as a result of fat producing a chronic inflammatory condition. And we've already talked about the risks that are associated with a chronic inflammatory state when we talked about inflammation earlier. And you can see straight away that since obesity does seem to be a chronic inflammatory state, that would mean that it would have a higher risk for a number of diseases, including cancers. So what we have as a result of this obesity and the flow-on of effects that we've just discussed is we have increased blood lipids. So we have a combination of increased triglycerides, for example, increased release of triglycerides into the circulation, and abnormal HDL function. That can't be good, and it isn't good. In addition to that, we have increased glucose chugging around in the blood and causing harm and mischief by its presence there. We've got increased insulin secretion, which in turn causes problems of its own, including activation of the renin-angiotensin system and the release of inflammatory mediators, both via activation of the renin-angiotensin system and in its own right. So what we have here is a sort of collection of effects that start off with obesity. And this has been characterized now to the extent that we call this collection of problems metabolic syndrome. So you would be considered to have metabolic syndrome if you have any three of the following 5 things: abdominal obesity, high blood pressure, elevated blood glucose. Fasting blood glucose is above normal. That would suggest that there's insulin resistance happening there. If you also have high triglycerides and low HDL levels, that is the constellation of problems that we now refer to as metabolic syndrome. And it is a problem because more and more people are getting it. We know that it is related directly to obesity, and particularly to that abdominal obesity, and it is associated with a greatly increased risk of cardiovascular events, stroke and heart attacks, but also of cancers and other serious illnesses. So metabolic syndrome is a new emerging syndrome that is a direct result of the obesity epidemic. That's not good news. But there is good news, and that is we don't have to get metabolic syndrome. It's within our power not to develop in the first place, but also to treat it in people who have it.